As a third example in the same vein, let's take a look at the same differential equation on the left, but the right-hand side's a little more complicated. So here we can say that our non-homogeneous function y is going to need to have t squareds in it. Somehow I'm going to need to have t squareds. Otherwise y prime, y double prime won't get me a t squared. We also need a constant. It might be possible that y has a constant in it, and then it's zeros for the other ones, but y better have a constant in it. But under the same logic as before, if we put t squared in y, then y prime's going to have t's in it. At the end of the day, it's like there's 0 t's here, but t's are a natural product of putting t squared in y and then computing its derivatives. We're going to get t's naturally. So we're going to need t squareds, constants, and t's in y to make this work. So what do? We're going to assume that y, the non-homogeneous solution part, is going to be some combination of, let's do them in order, t squared, t, and the constant, just c, where these a, b, and c are undetermined coefficients. And we know that we can figure out what values they should have by subbing into the differential equation. To accomplish that, of course, we need its derivative and its second derivative. So we're going to need this prime, which will be 2at plus b, and we'll need its second derivative, which will simply be 2a's. All right, we have our differential equation. We're going to sub into that, and that's going to give us 2a's minus 3 y primes, 2at's plus a b, minus 4y's. Y is the big long one in this case. bt and c. All of that has to equal, let's put this in the same order, 4t squared, no t's, 0 t's, minus 1. Our next step is to group the functions. In this case here, it's the t squared, the t, and the constants. Those are 3 linearly independent functions. Constant doesn't seem like a function, but it is. It's just a really dull, unchanging one. But if we group by those functions, we're going to get minus 4at squareds plus, let's do t's, we have minus 6at's here, we have minus 4b's, bt there, and for the constants, we have 2a's plus minus 3b's, minus 3b, minus 4c's. That has to all equal 4t squareds plus 0t's minus 1. So guess what we do next? If those two things are equal as functions, if I said this was a parabola and this was a parabola, they would only be the same if the coefficients were identical. And if the coefficients are identical, what we have to have is minus 4a has to equal 4. And I'm going to clarify what we have for the coefficients here, the t squared. The t coefficients, minus 6a minus 4b, is going to equal 0. And the constants are the most complex one. We're going to have 2a minus 3b minus 4c's has to equal -1, the constant coefficient on the right-hand side. Well, this looks promising. We have 3 unknowns, we have 3 equations, and all that we've done is used our intuition about what has to be in y to achieve a right-hand side that has t squareds and constants in it. Well, our y has to include t squareds and constants, and because derivatives are also involved, any potential derivatives, which in this case here is simply the t's. We've now boiled that down to 3 equations with 3 unknowns, 3 undetermined coefficients that we can now solve for. With this set of equations, let's call them 2, 3, and 4. We can fairly quickly narrow in on our values, especially because number 2 is so simple. A is going to equal -1. And then what we can do is put that into 3. That's going to give us positive 6 minus 4b equals 0. And so b is going to equal 6 over 4, or 3/2. And then we can put those both into equation 4. Negative 2 minus 3 times 3 halves minus 4c's is negative 1. Bring the 4c over, and we'll have plus 1. Minus 2 minus 9 halves plus 1 works out to 7 halves overall, and so c would equal 7/8. And there we have our solution. Our non-homogeneous part of our solution would equal a, which went with, remember the roots here, let's go back to our assumed form. A was the multiplier of t squared, then b went with t, and c was the constant. So the a, negative 1, goes with t squareds, the 3 halves goes with the t, and the 7/8 is the constant term. That is a solution to the differential equation y double prime minus 3y prime minus 4y is equals t squared minus 1. And again, that careful balance has been achieved where the derivatives of these terms all cancel out as necessary, so there's no t's when we're done, but there's still 1t squared and a negative 1 when we work all the details out.